SQL Language Basics. Not gonna lie, this lecture is filled with information you can learn for free online. Realizing that, guess what? I'm making it available for free online as a preview lecture. If you are watching this and not yet a student, rest assured that the statement, "It's not available for free online unless I put it there," remains true. No, but for real. This is an intro class, and I assume no prior knowledge. Because of that, I have to start you out with the basics, which include lessons in syntax and the ever-present "Hello World" example. This lecture is made in San Antonio by folks that know what an Intro to SQL lecture is supposed to look like. All those other basic SQL lectures and tutorials you see on the internet are made in New York City. If you haven't found them yet, I have some free code tutorials that can be used in conjunction with this class. There is a tutorial on T-SQL in Python. We will not be covering the material in the Python tutorial at all. We will be covering most of the material in the T-SQL tutorial in some shape or form. We will only be covering the basic and advanced sections and selected portions of the solutions section. Of course, we will be covering these topics in far more detail than you'll find in the tutorials. You can find links to the tutorials in the class workbook. In general, for this class, all code lectures will follow the pattern of tell, then show. We're going to talk about all concepts for the day first in lecture. Then I'll switch over to SSMS to demonstrate what I was talking about. Okay, let's get started. Structured Query Language, or as we pros call it, SQL. SQL is one of the first programming languages I learned. It's also my most used programming language. It's incredibly easy to learn. Every single SQL statement starts with 3 words: select, from, and where. Select the columns that you want, from the tables that you want them, where the data meets these filter criteria. If you understand that, then you're halfway home. Programming languages have to conform to national and international standards. The reason being that we have to make sure that the SQL you write in the States is the exact same SQL you would write in India, Russia, Saudi Arabia, etc. One body that manages standards in general is called the American National Standards Institute, or ANSI for short. There is an ANSI standard for SQL. This standard represents, in general, what SQL needs to be able to do in all relational databases, with some minor exceptions allowed. In day-to-day parlance, we refer to standard SQL as ANSI SQL. By comparison, T-SQL is the Microsoft proprietary implementation of SQL. Most, if not all, database vendors have their own flavor of SQL that works with their specific RDBMS. An example of that would be SQL, which is the language you use when working with Oracle databases. T-SQL implements most of ANSI SQL. It also extends the basic functionality of ANSI SQL. For the purposes of this class, I don't make the distinction between ANSI SQL and T-SQL and use these terms interchangeably in the context of SQL Server. In general, most of the basic functions of T-SQL are ANSI SQL, so at the end of this class, you can claim that you know ANSI SQL as well as T-SQL. SQL, like relational databases, has its foundations in mathematics. One important mathematical concept is set theory. A discussion of set theory is beyond the scope of this class. I bring it up because when I teach you how to write complex solutions, I'm going to be talking about creating set-based solutions. You don't need to know the math. Just understand where I'm pulling the word set from. With an analytics use case, the ultimate goal is to write SQL in a manner that asks questions of the data warehouse. The results of your SQL query will provide the answer. When it comes to writing analytic queries, don't think about the table schema or the relationships. Think in terms of how do I ask this question? What are the elements needed for an answer? Any labs where I ask you to write a query, I don't do it by giving you a set of specifications. I keep it real world and ask you to answer questions about the historical performance of the business. There are actually 5 kinds of SQL statements, but you'll only hear 2 being used out in the real world and specifically in interviews. So you need to commit this to memory, not just for a test. Actually, now that I'm thinking about it, be aware that I don't test over trivia. If it's on a test, it's information you need to do your job. DDL, or Data Definition Language, are those SQL statements that you use to manipulate database objects. The lecture titled Creating Database Objects with T-SQL is all about writing DDL. With DDL, you can programmatically create things like tables and indexes. All database table functions that you can do with SSMS, you can do with T-SQL faster and with a finer grain of control than just leaving table creation up to database defaults. Functions, views, and stored procs are all created and maintained with DDL. Those objects cannot be created through the GUI, so you will be writing DDL as a matter of course. DML, or Data Manipulation Language, gives us our CRUD ops. CRUD ops is a term I use frequently. It stands for Create, Read, Update, Delete. These are the basic functions of the database: creating data, retrieving data, updating data, and deleting data. DML lets us do these things and will be the overwhelming majority of the code that you write. There is a question mark beside the word select. That question mark is there because technically, select is what is called DQL, or Data Query Language. Nobody breaks the different types of SQL down that far in the real world, so we're safe shoving select in with the other DML. I know you're looking at SQL reserved words that are unfamiliar. At some point, we will go over these terms. Actually, we're going to start that process right now with a discussion on basic syntax. The elements of a SQL statement are called clauses. Clauses have to be written in a certain order. You cannot deviate from this order. If you attempt to perform an operation out of order, your SQL statement will fail to execute. Here, we see the order your clauses have to be in. Select, the columns you want to look at. From, the tables the columns live in. Where, your specified filter conditions are met. Group by, the columns you wish to summarize data on. Having, the conditions you specify when you are grouping and summarizing data. Order by, sorted by the conditions you specify. Each one of these clauses, in conjunction with other elements of SQL, gives you fine-grained control over how data is retrieved from the database. Here's an example of a basic SQL statement. Here, we are pulling the first and last name of someone from the person table in the person schema and with the last name of Johnson. With a name like Johnson, you can expect more than one result. However, having the filter will reduce our result set to just those people with the last name of Johnson. A quick note here. Normally, when you write your from clauses, you can just write the name of the table. You can do that for any table in the SQL Server DBO schema. But most tables in the AdventureWorks database belong to a user-defined schema, so we have to include the schema name in our query. If you forget to include the schema in the table name, your code will throw an error. In this lecture, we are just going to focus on select, from, where, and order by. Before we dig into that, however, let's talk about code comments. Code comments are common to every programming language that I am aware of. They are a way to leave notes in your code. Leaving comments in code is an important part of the documentation process. Believe me, code comments are not just for other people. They are for you as well, because you will straight up forget why you did something. Commented text in a SQL file will not be executed by the interpreter. There are two kinds of code comment techniques: single line and multi-line, as shown here. Single line comments are simply two dashes in front of the text you want to comment. Multi-line comments begin and end with a forward slash and a star, with the star being the closer character to the text you want to comment. As you'll see when we get to creating stored procedures, commenting out text has more uses than simply writing notes to yourself. They can be used to create clear sections to your code, which is important because SQL isn't an object-oriented language. But I'm getting ahead of myself. Let's talk about the basic methods to pull data from a database, starting with the ins and outs of the basic select clause. The select clause is how you control the output of your query. You have a lot of options here, and it can get complicated. Using the wildcard operator, you can show all the columns in a table without having to type them out. You can pick and choose which columns you'd like to display and the order in which they are displayed. You can change the format of a column name or change the name of the column entirely. You can alter how data is displayed with string and format functions. You can create new columns from existing data using calculated fields. You can display data based on conditions with case statements. This is not an exhaustive list of things you can do with the select clause. However, it does cover what is going to be taught in this class, because I believe there are certain things you can do with a select clause that you shouldn't be doing. Also, we are not going to talk about case statements just yet. That will come in the next lecture. SQL has what is called a wildcard operator. It is represented by the star character or shift 8. The wildcard operator is a special reserved character that you can use to tell SQL that you want all columns to be returned by your SQL statement. Those columns will be displayed in the order in which they were placed in the schema. The wildcard is handy when you're doing research and development work on a process. However, it should never be used in production code. And that is the last simple thing we're going to talk about. In production, you are usually going to limit the number of columns that you are displaying. Even for research and development purposes, you will probably want to limit the output to just what you care about. There are a couple of reasons for that. 1, tables can wind up having dozens of columns. Trying to look at a long result set can be infuriating. 2, and most importantly, when you run a query, you are reading from disk and dragging those ones and zeros across a network wire. Each column in a row stores X amount of data. The more columns you output, the more data has to be dragged across the wire. It matters, especially in an analytics use case where you may be returning millions of records. One row of an entire table may be 1 megabyte of data, times, let's say, 40 million records that represent the entirety of an enterprise's customer base. That data set is 4 terabytes of data. First of all, your ability to output data to SSMS is limited by the amount of RAM in your machine. You can choke your local machine by getting it to return more results in SSMS than you have the RAM to deal with. Secondly, in the scenario where you are outputting this data to a different disk, it takes time to write that much data to disk even for SSDs. Yeah, I'm getting ahead of myself a little. Just be aware that the number of columns you output does impact the performance of your code. All that said, getting the columns you want is a matter of simply writing them out in the order you want them displayed. The only catch here is, SQL is case insensitive. However, if the server is configured to the standards that I am going to teach you, i.e., using a case-sensitive collation, then you have to write the column name exactly as it is in the schema. You can change the names of columns using column aliases. Column aliases let you rename a column by using the SQL keyword as. There are a few different reasons you would want to rename a column. 1, when you create a column based on a calculation, SQL Server does not automatically give it a name. You have to do that. 2, when you are creating views for users, you do not want to use ugly database names. You can rename the column to something that will show up pretty in the user's BI tool. 3, sometimes you want to rename things for your own personal sanity. When you are pulling data from more than one table and those tables have the same column names, it can become confusing in a hurry. In the case of scenario 2, you may want to create a column name with a space in it. To do that, you have to wrap your alias in brackets. Now we're going to start getting deep with SQL Server built-in functions. SQL Server comes with a set of functions that allow you to do various things without having to write code. In time, you are going to want to read the whole T-SQL reference manual. This is something you might resist doing. Compared to some other languages, T-SQL is relatively small, and working through the manual isn't an impossible task, like it is for some languages, like Java. The reason you want to read the documentation and not just rely on what you are being taught in this class is, it is important to witness the firepower of a fully armed and operational programming language. No, seriously, you need to understand what a programming language is capable of, and we cannot cover the full capability of T-SQL in one class. That is why this is just one class in a sequence. That said, we will cover all the stuff you need to know to develop warehouse ETL. We are going to cover the 99% of use cases that you will run into out there. Reading the full T-SQL standard will help you cover the 1% edge cases that you will run into from time to time. An important thing you need to know about T-SQL is that it is a one-based index language. What that means is when you are doing things like counting characters in a string, T-SQL starts that count at 1. By comparison, many other languages are zero-based indexed. When you become a high-speed data professional and start working with more than one programming language to get things done, understanding little differences like this will save you a lot of embarrassment by preventing you from writing code based on a different language's standards. The first set of functions we are going to talk about are string functions. As the name suggests, string functions work on string values. Strings are character data types. Almost anything can be stored as a string. However, as we'll see later, that isn't always the best way to store a value. String functions allow you to manipulate data so it displays a certain way. If you work in analytics, you are going to be spending a lot of time manipulating strings. You are pretty much going to use all the string functions at some point. For this class, we are going to focus on the string functions you will be using 99% of the time. This is an opinionated list of frequently used string functions. Let's discuss them one by one. Concat. You will frequently need to smush values together. When I teach you how to hash values to determine uniqueness in a row, it is the concat function that we will be using. Len. Len is useful when we're trying to determine the length parameter of string data types in table schemas. We'll do an analysis of the data using a combination of functions, including len, where we will go and determine what is the longest string character we have. You have to be careful with len, because it does not count trailing spaces. When we talk about data cleansing, I'm going to be stressing the importance of finding and eliminating extraneous characters in data, one of which is trailing spaces. Char. Functions return data. I probably should have explained that, but I wanted to hold off really talking about functions until we start talking about hardcore programmability. For now, just understand that functions have inputs and outputs. In T-SQL, we don't really think too hard about function parameters like we would in Python. So, for now, we can keep it vague. The reason for that little side quest was because sometimes, like len, the input to a function is a string, and the output is a number. Sometimes vice versa. Sometimes the input of a function can be the output of another function. That last case is where char comes in handy. We will use char to find and remove things like carriage return and line feeds. All right, Computer Science 101. Everything inside the box has to be represented as some kind of number. In digital computing, the smallest something can be represented in is a 1 or a 0. This is called a bit. We then take binary values and group them into 8-bit groups called octets and use that to represent values from 0 to 255. The position and value of a bit in the octet determines what a bit represents. Once you figure that out, you just do math to determine what value the whole octet represents in a base 10 number system. Everything you type in can be represented by a number from 0 through 255. That includes characters you can't see, like carriage returns and line feeds. All that is fun trivia, but what you really need to know is that these values can be found in something called an ASCII table. An ASCII table maps decimal values to their character equivalents. The decimal value is what goes in as an input to the char function. You stick that number in, and out comes the character representation of that decimal value. That comes in real handy when you're looking for things like carriage returns and line feeds that we cannot see, but routinely messes up our processes. It's such a common issue that I have sample code to tackle that problem, which I'll show you later. Left and right. If you want to chop off a string so it only shows a certain amount of characters, you use the left or right function depending on which end of the string you want to start counting on. ltrim, rtrim, and trim. These functions remove spaces from the left, right, or both ends of a string respectively. ltrim and rtrim are pretty old. You have to be careful with trim. It's more useful, but newer, so it can only be used in SQL Server 2017 or newer. If you try to do something and you get a syntax error, but you know you coded it properly, the first thing you want to check is if you're using an older version of SQL Server. Organizations like to mix their environments by not upgrading boxes all at once. You could be coding a process that only works on one particular box. It happens. Then you have to go back and refactor. Using newer functions is fun and easy, but sometimes it's better to err on the side of caution and use older techniques. Replace. Replace is the function that we're going to use in conjunction with char to find and remove hidden characters in data. Replace is the SQL version of find and replace. I frequently use it to remove the space between characters. Replace is cool in that, unlike other SQL functions, it doesn't just replace the first instance. It will replace all instances of the specified search target. And finally, we have substring. Substring is like left and right, except you don't have to start from the end. You can pick out some text from the middle of a string and then define how many characters you want. Counting still starts from the left, though. When it comes to formatting output, you really want to leave that up to the reports developer, whomever that may be. Your job is to get that person data so they have maximum options about how they display it. We do not want to be making format decisions upstream. There is a format function that lets you do things like put $signs on numeric values. We don't want anything to do with that. The primary concern of data engineering is storing data efficiently. That means doing things like converting values to something that can go in a specific data type. You do that with the cast and convert functions. It's too early in your training to start talking about data types. I bring it up now so you understand that when it comes to outputting data in a manner that is pretty to users, that is somebody else's job. Formatting to us is getting data in the proper shape for storage. It is possible to derive new columns from existing information. You can use the select clause to do basic arithmetic on columns with numeric data in them. Like I mentioned before, when you do this, SQL Server will not automatically give the new column a name. You have to do that by giving your calculation an alias. The values in the columns that are components of the calculation have to be either numbers or values that can be converted to numbers. We will talk more about this when we get to our discussion on data types. For now, let's move on from the select clause and talk about the from clause. At this point, we can't say much about the from clause. Every example in this lecture will be pulling data from a single table. From doesn't get exciting until we start talking about joining tables together. There is one thing we can talk about now that will set us up later for doing multi-table SQL statements. There are two kinds of aliases. We already talked about column aliases. The second type is table aliases. Table aliases let you rename tables. There are a lot of reasons to do this. Those reasons will become apparent when you start pulling data from more than one table. A table alias makes it easier to refer to a table and helps you keep columns straight. To alias a table, just put what you want to call the table behind the table name in the from clause. There are no rules here, except the standard rules for SQL. You can name it anything you want. However, we do aliasing so it's easier to work with tables. So what you want to do is give the table a nickname. When you do this, for the life of that SQL statement, that table in the from clause will be identified by whatever you called it. That means that column names can also be referenced by the table alias. Right now, it's not a big deal because we're only dealing with one table. When we get to joins, specifying which table a column comes from will be required. It's a good idea to just start right now, referencing columns using a table's alias. Almost done here with the lecture portion. We're now going to talk about how to filter your result set with the where clause. Quick side quest for more Computer Science 101. This time over Boolean logic. Logic operators are only about two things: whether or not something is true or false. Ultimately, it's all about ones and zeros. The way computers currently work is that everything inside the box exists in one of two states. It is either on or it is off. Currently, there is no in between. Open up the case on your computer, and all that whiz-bang stuff that you are looking at breaks down to something being on or off. In the computer, this on or off state is represented by the numbers 1 and 0, with 1 representing on and 0 representing off. On and off also can be represented by the Boolean data type values of true and false. The reason is the binary nature of the current state of computer engineering. Eventually, we'll get to quantum computing where we can evaluate states between 1 and 0. But it's going to be a while before that tech is commercially available. When you are testing values and conditions, you are testing whether or not the current state of the value or condition is either true or false. That is fairly straightforward. 5 is greater than 1. This is true. 5 is less than 1. This is false. When you are writing business logic, you can write instructions based on whether or not the result of the evaluation of a condition is true or not. The real fun of Boolean logic begins when you have to start combining conditions or test. Now you have to decide how much or how little of the combined condition test has to be true in order for the entire thing to evaluate to true. 5 is greater than 1, and 10 is greater than 5. This is true. 5 is greater than 1, or 5 is greater than 10. This is also true. The second statement is true because you told the computer that it was okay if only one statement was true by using the OR keyword. When it comes to Boolean logic, your basic options are: in order for the condition test to evaluate to true, the entire condition test has to be true. In order for the condition test to be true, at least one component has to be true. In order for the condition test to be true, the entire condition has to be false. Condition tests can be incredibly complex enough that it can give you a headache trying to figure out if something should evaluate to true or false. In the strongest terms possible, I recommend that you do everything you can to keep your condition test simple and straightforward. Let's have a go real quick at some basic logic problems, just to see if you understand so far. I'm going to flash up some binary values and logic operators, and you try to figure out if the test condition evaluates to false or true. True and true evaluate to what? Yeah, that one was easy. Two things that are both true are going to evaluate to true. Next one. True and false evaluate to what? True and false evaluate to false because the AND operator requires that both values be true for the whole condition to be true. One more warm-up question. True or false evaluate to what? True or false evaluate to true because OR just wants either value to be true for the whole statement to be true. Playtime is over. Here comes a curveball. True and false, or not false, evaluate to what? Now what, Chuck? Throwing in parentheses changes the whole game. You can't simply evaluate left to right. It's just like basic math. Do the stuff in parentheses first. True and false evaluates to false. Not false evaluates to true. What you are left with is false or true, which evaluates to true. Fortunately for y'all, it doesn't get that much more complicated when it comes to writing logic with T-SQL. I mean, y'all think this is bad? Imagine sitting in Intro to Computer Engineering having to deal with this nonsense. Hard pass. Leaving computer science for management information systems was one of the best decisions of my life. But I digress. The where clause is how you filter the data that you want to look at. A basic filter consists of a column name that you want to filter on and the conditions of the filter. When we filter on string values, you have to enclose the value within single quotes. Other data types do not require this, and you will learn which ones over time. Data can be filtered in a lot of different ways. You can be very specific in order to get exactly what you want. Filters are built with logic operators. The logic operators in SQL are very much like the logic operators you will find in any language. If you are new to programming, don't worry. We'll go over each of these. Half of these should be familiar from whatever they call early primary school in your part of the world. In the States, it's called grade school and usually consists of children aged 5 to 12. That is how basic this is. The first weird thing might be does not equal with the whole exclamation point out front. Side quest. In computer parlance, we call an exclamation point a bang. In SQL, a bang is another way of saying not. So, if there is a bang in front of a logic operator, that bang effectively reverses the meaning of the original operator. Some operators are in plain English, and it will take you a while to get the hang of when to use either the math operator or the English operator. This is the general form of a where clause, where clauses are equalities or inequalities that have to be satisfied, usually in the form of one or more columns meeting your specified condition. I want you to get into the habit of writing ablation testing ready queries. You will learn what that is later. For now, every query with a filter should have at least 2 filters. The first filter should always be setting 1 equal to 1. Since you are going to have at least 2 filters, you have to combine the filters in a way to make sure you get what you want. Combining filters requires the use of 2 additional operators, and for when you want both conditions to be true, or for when you want either condition to be true. Combining filters can be quite complex and confusing. For readability and your own sanity, I recommend that you keep everything straight by using parentheses to clearly group your logic. That said, using parentheses can be a double-edged sword when you're writing OR logic. I'm a huge fan of between. So huge, between gets its own slide. The reason I love between so much is because I love readable code. I'll take actual words over math symbology any day. There is a catch, though, and this is going to be true of several other aspects of the things I'm going to teach you. I love readable code so much that I'll take code that I can read over performance. I will straight up inconvenience some users with just slightly slower than normal queries, just so I don't have to look at janky code. Technically speaking, trying to find data between 2 values using math symbology is faster than using between. Why is that? Don't know. Don't care. Doesn't matter. Remember what I said about viewing the data ecosystem in its totality? See the whole board. I once did some A/B testing between 2 different techniques. What I found was the results I got were orthogonal to which technique I used. Instead, the variance in performance was more attributed to how much data I was pulling back, the specs of the server, and a bunch of other stuff that had nothing to do with technique A versus B. In general, I'm too old to engage in nerd fights. All I care about is, does it work? Yes. Does it mean I don't have to look at janky code? Yes. Okay then. Let's use that and keep it moving. SQL actually has 2 wildcard operators. There is one for the select clause and one for the where clause. However, unlike the one for the select clause, the one for the where clause needs a partner to work properly. This partner's name is the like operator. Like functions exactly like it sounds it does. It allows you to filter on string values that are only partial matches instead of exact matches. The last element of filtering we are going to talk about is the in operator. The in operator lets us match on more than one value without writing numerous and lines in your where clause. In many cases, the number of values you might want to match on is so numerous that it would be impractical to write that many and lines anyway. The last clause we're going to talk about in the basics lecture is the order by clause. Order by lets you control the order in which data comes out of the database. Ordinarily, data comes out of the database in the order in which it is stored on disk. This order is defined by any indexes on the table. Order by lets you override the indexes. Data can be ordered in ascending order or descending order by using the ascending or descending operators respectively in your order by clause. You can order the data using as many columns as you like. You can even specify ascending or descending on each column. If you can't tell, I'm getting short on words because we're getting short on time and we still need to see this code in action. What you've learned in this lecture will be revisited in later lectures as I teach you to employ these basic concepts in greater and greater complexity and sophistication. All right, let's spin up SSMS and see some of this theory in action. If you have read more than one coding tutorial, this should look pretty familiar to you. I'm sorry I have to do this to you. But I swear, if I don't start with a hello world example, I'll tear a hole in the space-time continuum. No, really. That's the rules. Look it up. It's just science. And now, thanks to me, you can keep living a life free of transdimensional monsters. You're welcome. For such a simple example, there is actually a lot going on here. First of all, I want you to get into the habit of identifying the database you are using by using the use statement. It will save you a ton of heartburn in the future when you're executing queries off the wrong database and you don't notice. The second thing is line 3 represents the bare minimum SQL statement, just a free-floating select clause in what is known as a string literal. As you can see, this is perfectly legal SQL. Line 5, however, I wouldn't call a legit SQL statement. Most programming languages I know have a way for you to print to standard out, which is usually a command line, or what is known as a REPL when you're working in a GUI. Print is how you send stuff to the system standard out, which, like I've mentioned before, is the Messages tab. If you click on that, you'll see our message to the world. Print is a debugging tool that we will be using more as we start doing more complex things. Finally, if you flip back to the Results tab, you'll see what I've been talking about when I say if you create data out of whole cloth, SQL Server will not name your column for you. All right, enough of that tomfoolery. Let's take a look at some real SQL statements. We are going to pull some data from a table. The goal will be to retrieve all records from a single table with no filters, so our query will be 3 lines. We will create 3 queries. The first query will display all columns in the table using the SQL wildcard operator **. The second query will display only the columns we want displayed. The third query will demonstrate that I control the output by reversing the order of the columns from the second query. We'll run these queries at the same time because we're not really scrutinizing data yet. As you can see, one query just vomited out every column in the table, while the second result set is much more manageable, and the third result is just for the lulz. I'd like to point out that since the EDW implementation of AdventureWorks doesn't use user-defined schemas, I do not have to specify the schema in my SQL statement. Using the DBO schema for the base tables in your EDW implementation is really poor physical design, which is a horse I will beat and a hill I will die on in a later lecture. Let's play around with renaming columns and tables using aliases. I need some information from the product dimension, but I don't really care for how the columns are named in the database. I'm also annoyed with having to write out product because I'm super lazy like that. I'm going to be the change I want to see in the world and use SQL to enact my radical agenda of column names with spaces in them and table names that only use one letter. I mean, it's practically socialism. I also don't like the idea of other countries being allowed to name my product, so I'm going to do something about that because Merca. The man that is keeping you down, aka the SQL interpreter, demands that object names not have spaces in them. Fortunately, the man also gives you a way to stick it to the man by wrapping object names with spaces in them with brackets. And boom! You're yawning. You're not impressed. I get it. This is lame. Trust me. You're going to be thanking me when you're putting together SQL statements with 10 tables and some of those tables are sharing the same column names. When that happens, aliases will seem like a godsend. Let's keep it moving. I'm going to walk you through all the string functions. Calculated fields we'll talk about again in SQL Basics for reports development. Formatting I'm going to hold off until our discussion on data types. I'm also going to wait to demonstrate char so you have the proper context in which it can be used most effectively. Here we have an example of every string function we discussed. Some functions like rtrim are hard to determine if anything is happening because the data in AdventureWorks is very clean. I'm going to execute these statements one by one so we can examine the output. First up, concat. I wrote all these queries so you could see the before and after state of the data. The integrity of the original data has been maintained. I've just pushed all the values together. This will come in handy when we need to do things like hash the concatenated values of the records in junk dimensions to determine row uniqueness. Next and in no particular order, len. Before I go on, I just realized that I've been a bad boy. Remember how in the dimensional modeling lecture I said you have to make sure you are pulling the most recent record when asking questions off dimension tables because some of them carry history? I haven't been doing that, have I? Is this a good way to educate the future data professionals of the world? No. Am I going to fix it because this is a recording? Also, no. I'll be sure to pick up the habit next lecture, and for the rest of the course. Now, where was I? Oh yeah, counting characters. Probably owing to the fact that I wasn't checking for dim product.status equals current, my initial query returned null values, hence the and after the where. But if you're willing to turn a blind eye to my complete and total lack of professionalism right now, you can see len returning the size of the string. Obviously, I don't expect you to double-check unless you have that kind of free time. You can just mark one eyeball it by dragging the description column across and see that the smaller sentences have lower counts. This may seem a little abstract. Why on earth would we need to count characters? For a lot of reasons that I'm going to cover in great detail in later lectures. Next, left and right. First, we're going to only display the left 20 most characters, then we're going to display the right 20 most characters. Yep, and we can mark one eyeball that just by visually seeing that the left part of the sentence is intact while the right gets looped off in the output column. And now we can check the same in reverse. Excellent. I'm also going to take a pass on showing you the trim functions. In order to do that, I'd have to mock up some data, and you're not ready for that kind of defense against the dark arts professor level skill yet. We'll hand-wave trim for now and see those guys down the road a bit. All that leaves is replace and substring. First, we're going to replace the word road with street. Next, we're going to go into the middle of the description 10 characters and return the next 15. And you can mark one eyeball that result as well. Before we run this next set of queries, let's get a count of the total records in the table. There is more than one way to do this, but right now, you're just playing the game with a wooden sword, and you need to defeat way more enemies before I start handing out the good stuff. So here is the super clunky way to get the amount of records in a table. Just run a query wide open and check the number in the right-hand bottom corner of SSMS. Now that you have that number in your head, you can use it as a cross-check to confirm that we are indeed getting back less than all the records when we apply our filters. We are going to start off easy, and the filters will get more redonkulous as we go. I've constructed these examples so the column that we are filtering on is outputted, so we can see if our filter is indeed working. The first two are straightforward, single condition filters that we retrieve records where reorder point is greater than or equal to 600. In scrolling down, we can visually check and see that there are indeed no records less than 600. Let's run the next one. Here, we'll look for every value of safety stock level that is not 1000. And double-check the result. In the next one, we get to use my favorite filtering tool, between. I normally use between to filter for values between certain dates, which is a common use case in business analytics. Just a personal coding quirk, but if I'm searching for something between numeric values, I prefer to use math symbology over between. The key thing you need to understand about between is that it is inclusive of the boundaries of your search. The column that we are searching on is a date, so we have to pass the between operator to dates. When it comes to dealing with SQL Server and dates, I do two things. In code, I represent them as string values. As long as a string value will resolve to a valid date, SQL Server will treat it like a date. The other thing I do is represent dates in the format of 4-digit year, 2-digit month, 2-digit day. Representing the date in that format has some benefits that are not immediately obvious to new people. If you lead with the year, that means, under most normal circumstances, and I mean only in the edgiest of edge cases would this not be the case, the value of the date will be a non-zero value. That means as long as the rest of the data is also numeric, a date can be stored as a number. That means you can efficiently sort on date and perform math on dates without explicitly using the built-in functions for handling dates. It also means that you will be able to interoperate with the primary key of the date dimension, which does actually store the date in that exact format and as a number. Make your life easy and store dates the way I do. Okay, enough talk. Let's light this candle. And we get back exactly what I asked for. The first 7 days of January 2005. The next example throws an OR into the mix. Listen, before we go any further, I need you to understand that I hate OR logic. Guys, I've been doing this for 20 years, and I still screw up OR logic. I go out of my way to avoid having to include an OR in my filters, and I'm only teaching you about OR for completeness. It would have been real weird if I would have been like, and here is and then just moved on, like OR wasn't a thing. So we are not going to get too crazy with OR because I don't want to embarrass myself. Go ahead and laugh, and then DM me when you have an OR clause that keeps bringing back records you don't want even though you're 100% sure you're doing it right. This is pretty simple. We want all the records where the size has a value or the color is black. I'm going to hand wave the idea of null for a moment. When we run this, you can immediately see the impact of using OR versus AND as we get back records where the size is actually null. If you look closely, you'll see that every instance of size being null, the value of color is black. This next query, I'm going to let you puzzle out and determine whether or not the result set returns what you think the code says it should be returning. Post what you think in the DEng 100 channel in the student lounge. The next query is an example of using the in operator to filter on a range of values. Let's run it. And check and works. Next. In the last query, I'm combining some concepts. I'm using the where clause, wildcard, in conjunction with the like operator to find values that start with HN. I use the select clause wildcard filter to show all columns, but I'm making them show after my column of interest. Sometimes I do want to see the whole result set, but I need easy access to the thing that is driving the result set. If I put it out front like this, I can see the values of the column without having to scroll to the right and waste time looking for something that might be buried in over 50 other columns. Ordering data in SQL is kind of like ordering data in Excel. You can use as many columns as you like, and the sort will be organized from left column to right in order by clause. You can even mix it up and have some columns sort ascending and some sort descending. That is what is happening in the last query. SQL Server has a default value for ordering data when ascending or descending isn't specified. I have no idea what that value is, and I don't care. I like readable code. No matter what, I specify ascending or descending because I don't really like guessing games. I'm going to leave it to you to run these queries. We're running out of time, and there is one more super important topic that I want to address. I love SQL, but it does have one serious flaw. The interpreter absolutely positively does not give a single solitary rip about whitespace. That's problematic, because unlike other languages like Python, which enforces rules on syntax, SQL is just the Wild West, and people do whatever they want in terms of style and coding standards. I am that rare breed of human for whom SQL is my primary language. Of course, I had learned other programming languages prior to SQL, but I never used them day in and day out. Most people come to SQL from other programming languages, and they have a tendency to bring their nonsense with them. People that come from other languages try to overlay whatever coding standard they have previously used onto SQL, which is a massive pet peeve of mine. What you wind up with is a mishmash of code inconsistently flowing all over the place as the individual engineer interprets where they think indents should go. Contrary to popular belief, this does not result in more readable code. If you left justify all of your code, at least you can use that as a universal coding standard that everybody has to follow. Over the years, I have developed my own code standards for writing SQL, which I would love to rant more about, but we're out of time. The code standards can be found in the workbook and are testable material. See you guys next time. Salud.